Nothing like a pocket of turbulence to get your heart racing when you're flying. It's the reason airlines encourage you to keep your seatbelt on throughout the flight. Now a new study is suggesting we might be dealing with more turbulence, and it's all because of climate change. Dr. Paul Williams, Department of Meteorology, University of Reading in the United Kingdom, joins us today. Hello, Dr. Williams.
Hello, Angela, and do call me Paul.
Well, let's start with just the definition of turbulence. What exactly is happening?
Yeah, what's going on is that it's irregular or chaotic motions in the atmosphere, so the wind is blowing in all directions randomly and basically pushing up against the wings of the plane. So that's exerting a force. The atmosphere is exerting a force on the wings of the plane and basically just pushing it up and down randomly, and also a little bit from left to right and backwards and forwards. But the main motion is the up-down motion, and that's what passengers experience. So it's a little bit like a roller coaster ride.
We experience pockets of turbulence. So I don't know if you can explain that, but it seems you can be flying smooth and suddenly, boom, you're dropping in your seat almost.
Yeah, that's right, and it's called clear air turbulence, precisely because it's invisible. So anyone who's flown through a cloud will know that that is usually, in fact, always a turbulent environment when you fly through a cloud. But even when you're flying above the weather and above the clouds in clear blue skies, you can encounter a form of turbulence called clear air turbulence that tends to be the most hazardous, and that's precisely because the seatbelt sign tends to be off. The pilots can't see this kind of turbulence. Not even the radar on the plane can see this kind of turbulence. So it comes without warning, tends to be the kind of turbulence that puts people in hospital. And yeah, it's a kind of a pocket, is one way of describing it, in which basically the plane can just plunge down by many meters. And if you're not strapped in, that means that in severe turbulence, which is stronger than gravity, basically the plane can be moving down faster than gravity can pull you down back onto your seat. So people do lift up out of their seats in severe turbulence, and it is the kind that can, as I say, can put people in hospital.
Now you have to tell me about your research, because it sounds like you're suggesting because of climate change, we may see more of these incidents.
Yeah, and it's not an obvious link, is it? But the mechanism behind it is that the atmosphere is not warming uniformly. So different parts of the atmosphere are warming by different amounts. So if I take you up to 35,000 feet, the tropical parts of the atmosphere near the equator, well, they're warming a lot more rapidly than the polar parts over the Arctic. And what that means is that the temperature difference between the tropics and the polar regions, that temperature difference is increasing, and it's that temperature difference that drives the jet stream winds. So the jet stream is becoming stronger because of climate change, and basically a stronger jet stream means more clear air turbulence, because the instabilities that cause clear air turbulence are just sitting there in the jet stream, and as it gets stronger, those instabilities become more intense.
Will it be in certain areas? I mean, as you say, the jet stream, it covers the world. So will it depend on where you're flying or even what time of the year you're flying?
Yes, it might well do to some extent. As you've said, the jet stream goes all the way around the world. So it comes over North America, including Canada, and it comes out over the Atlantic, over into Europe, over into Asia, and then across the Pacific, and then meets itself at the other end. So it goes all the way around in the mid-latitudes. We've crunched the numbers for transatlantic flights simply because that's a very busy airspace. Actually, it's the busiest oceanic airspace on the planet, is the North Atlantic Flight Corridor. So we've been calculating a 149% increase in severe turbulence in that flight corridor in winter. And it is in winter that this turbulence is strongest. That's because the jet stream is strongest in winter. So we're seeing those increases in winter, and we've crunched the numbers for winter. But I would expect a similar effect in other flight corridors apart from the North Atlantic, and also in the other seasons too. And we're currently working on those calculations right now.
Paul, any idea how many incidents of turbulence there is when it comes to airlines and the impact it has on their flights?
Yeah, there are some statistics. I mean, I should begin, because there are probably some nervous flyers listening. I should stress that turbulence is rare, or severe turbulence at least is rare. Only 0.1% of the atmosphere at 35,000 feet contains clear air turbulence that's strong enough to hospitalize someone. So if you're maybe heading to the airport right now, the chance of your plane encountering that 0.1% of the atmosphere is very small. So you're almost guaranteed not to hit turbulence for any particular individual person. But when you multiply that by the number of planes in the sky and the number of people flying, you don't have to wait very long before one of those planes will just randomly hit that 0.1% of the atmosphere. So we do know that there are thousands of planes every year which are encountering severe turbulence, and it does cause hundreds of injuries to passengers. Actually, most of the injuries are to flight attendants because they tend to be moving around the cabin and securing the cabin at the time. And on small planes, there are some fatal injuries, something like 40 a year, but that does not happen on the large commercial airliners. The rule in turbulence is the larger the plane, the smaller the response to a given patch of turbulence. So bigger planes are safer places to be than smaller planes.
Very interesting. And as you say, people are already sort of nervous about flying, so I'm glad you tried to calm them down a little bit. Dr. Williams, thanks so much for telling us about your research.
My pleasure. Thanks for talking to me.
Dr. Paul Williams, Department of Meteorology, University of Reading in the UK.